Okay, so this is kind of your first lesson. So the thing that I want to iterate to you is, first of all, this is just to supplement classroom, okay? So if we haven't covered something in class or you need to go back and look over something, this isn't to replace that, it's to help you out, okay? Especially in that studying. So if you need to go back, you forgot how to work something, this is what these videos are for. So let's talk about the standard before we get into the lesson. So we're going to be talking about points, lines, and planes, okay? And the first standard we're going to cover, partially cover, is to know and apply precise definitions of the language of geometry. We're going to understand properties of line segments today, not angles, not circles, okay? Understand properties of and differences between perpendicular and parallel lines. We won't get into that today. But we're going to talk about formal language of what line segments are, planes, what points are, and so this is where you start to understand some of the proper definitions. So we're going to get into it. So the first thing we've got is a point. So we want to know what the proper definition of a point is. So let me readjust this. Get this keyboard off of it. The first thing we're going to talk about is a point, and a point indicates location and has no size. So when you're working in geometry, whenever you're defining a point, you're going to mark it, and I'll show you what that looks like. And it's going to be marked with a capital letter, okay? So it says whenever you're naming or whenever you're labeling these, you're going to use capital letters. So as a picture, as a definition of what this looks like, here's a point. This is A, okay? The next definition we have is a line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points. Okay? So you've got two options with labeling. Option 1. You can define a line by any 2 points on that line. So let's say A and B are points on that line. We denote it with a line just above it extending in both directions. So 2 arrows pointing out connected. So AB or BA. Either way, that one. And then option number 2 is we call the line a lowercase letter, like L. So line L. And I'm going to give you an example. Okay? So here's an example of line AB. So I've got 2 points, point A and point B. And there's exactly one line that goes through both of them in the geometry that we're studying. And so this is line AB. Or I can come outside this line and label it L. So that is line L. And then we've got a plane. It says a plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many points, and that's all the definition is. Okay, so you've got a few options for a plane. Option number 1 is any 3 points on that plane, okay, that lie in that plane. So a plane is actually defined by 3 unique points that lie in that plane. Okay? So as an example, let's say R, S, and U are points in that plane, and I'll show you what I mean here in a second, but plane RSU. So I write the word plane and then write the 3 points just one after the other. Looks just like that. Option number 2 is plane B. So there's a letter that denotes the entire plane. So maybe it's called plane B, and it is an uppercase letter, okay? So let's kind of see what this looks like. So this is 3 dimensions. We've got X, Y, and Z. Let's say I've got some plane exists in 3 dimensions. So I've got 3 points. I've got R, S, and U. And then I call this plane B. Okay? So RSU are 3 points in that plane. So I can call this plane RSU, or this B down here denotes that this is plane B. Let me make sure you can see that. Okay. So then we've got collinear points. Collinear points are points that lie on the same line. Okay? So as an example, say I have a line and it's got points D, E, and G. Okay? So D, E, and G are all collinear. So coplanar is very similar. Coplanar are points and lines that lie in the same plane. So let me draw a plane here. Maybe I've got point A, point B, point F, and I've got lines extending out that lie in that plane, and then maybe some point C over here. Those are all coplanar, so that means they lie in the same plane. So if you worked in Algebra 1 last year, whenever you were graphing functions, they were all coplanar. All the points you were working with, they all lie in the XY plane, so they're coplanar. Any function that you dealt with was coplanar. It says, what are 2 other ways to name QT? Okay, so QT is this line here, and we talked about ways that we can name lines. So if you look back at your definitions, line is represented, option 1, by 2 points, okay, A, B, or BA. So they used QT. Let's think of some other options. I can use QT, I can use QN with a double arrow, or I can use TN with a double arrow, or you can switch the letters, okay? And then there's another name for that line. If you take a look here at the base of this line down here, they've called it line M. So I can refer to it as line M, okay? It says, what are 2 other ways to name plane P? Well, they've used that capital letter, so I cannot use that anymore. So plane P is out. But let's take a look at our definition. It says a plane is represented by a flat surface that extends without end and has no thickness. Plane contains infinitely many points. You have to have 3 points that lie in that plane, or the letter. So they've already used the letter, so we need 3 points that lie in the plane. So if I take a look down here, R lies in the plane, so I can call it plane R. Q lies in the plane, RQ, and then V lies in the plane. So RQV, or, right, SQV, S lies in the plane plane SQV. And it says name 3 collinear points. So 3 points that lie on the same line. So if I take a look here, TQN is one option. They're all collinear. Or I could look at this line, right? This line L, RQS. Or collinear. It says name a point not coplanar with R, S, and V. So it doesn't lie in the plane. So if I take a look here, right, R lies in the plane, Q lies in the plane, S lies in the plane, V lies in the plane. T and N do not. So T or N would be a proper response to that. Okay? And then we forgot to mention space. Space is the set of all possible points. So when we think of outer space, you could think of any point that exists out there. And it's not limited to that. Okay. Okay, we've got segment. A segment is a part of a line that consists of 2 endpoints and all of the points between them. So it says name a segment by its 2 endpoints. Well, it's going to be really similar to a line, except there's going to be no arrows extending out forever. So you can do segment AB or segment BA. And notice that they're just lines without the arrows, okay? And then here's what the picture looks like. Here's A, and here's B, and all the points in between. And segments are not lines, okay? You can think of them as parts of lines. Even though there's infinitely many points between those 2 points, it doesn't extend on forever in every direction. So let's talk about that standard again. Understand properties of line segments and angles and circles. So you've been introduced to line segments, and you kind of know the definition, how to label them. So that's what we're kind of getting to here. Let's kind of finish this out. A ray is a part of a line that consists of 1 endpoint and all of the points on the line in one direction. And let's talk about labeling. Labeling array. Name array by its endpoint and another point on the array. The endpoint must come first. So wherever you start. So they're saying endpoint. I like to say starting point. I mean, it doesn't matter. But you start somewhere at a singular point, and then it extends on forever. So ray AB would look like this. So here's A. So it doesn't extend on forever in this direction, but it goes out this direction. So this is just an example. I can take a ray to go any direction, but ray AB extends on forever like that. Okay? So this side is infinite. It infinitely it goes on forever in that direction. This side, there's nothing. So there's an end point. So I guess that's why they call it an end point. Opposite rays are 2 rays that share an endpoint and form a line. So CA and CB would be an example with the given picture here. Here's C. It goes on in that direction and in the opposite direction. So here's ray CA and here's ray CB. And I don't want you to get confused. It is a line, but lines can be thought of as two different rays. So there's one ray, there's the other. Okay. So then we've got, write this little exercise. It says name 3 line segments. Well, let's take a look at it. I know DE is a line segment. And I put that little bar above it. I know EF is a line segment. And then DF is also a line segment. Right, so I've got this line segment here, I've got this line segment here, and I've got this entire line segment there. Okay, name the 4 rays. Well, a ray starts and extends on forever. So let's say I start with E. I've got E goes out and forever in this direction, so that's ray EF. So that's one ray. And then I've also got ray ED, ray ED. So I go from E to D. And then I can think of, I can think of DE as a ray. And there's more, I think, than just 4. So DE is a ray. DF is a ray. And FD is a ray. So you can think of rays in more ways than one. So then we're going to get into some postulates. And if you look at the standard, kind of delve into standard, it says, students understand a more formal knowledge of postulates, theorems, and various properties relating to line segments. Okay? So angles and circles we're not going to cover. This knowledge is based on the undefined notions of points, line, distance along a line, and distance around a circular arc. So we're really talking about notions of points, lines, not really talking about distances yet. Okay? It says, through any 2 points, there is exactly one line, is what we want to say. Exactly one line. If 2 lines intersect, they intersect in exactly 1 point. Okay? So if I have 2 lines here, let me just talk about this. Through any 2 points is exactly one line. So there is exactly one line that can go through both of those. Okay? And it is unique. If 2 lines intersect, they intersect in exactly 1 point. Well, if I've got line L here and line M, doesn't necessarily need to look like this. They're going to intersect in exactly 1 point. And you kind of worked on this in Algebra 1, may get some more practice in geometry. Definitely going to get some more practice in Algebra 2. And then we got, if 2 distinct planes intersect, they intersect in exactly one line. And this may be a little tough to see, but like this plane, it extends on forever, and this plane extends on, ooh. This plane extends on forever, this plane extends on forever, but they intersect here. So this intersection here, that is the intersection of two planes, and it is a line, okay? And then it says, through any three non-collinear points, there is exactly, well, first I'm going to draw that. Kind of think about it. Let's say this is R, this is S, and this is U. If you think about it, well, there's 3 points. We talked about this earlier. You might not remember it. But that's why I kind of picked these points, because we did mention something about RSU. Through any points that are 3 points that are non-collinear, there is exactly one plane. Through them all. That intersects them, okay? So 3 unique non-collinear points, right? R and S are obviously collinear, S and U are collinear, but they're not all 3 collinear. That defines a plane. So then they've got this nice little image over here for us to work with, and it says, what is the intersection of plane CUE, so this plane here, with plane EBT. So this plane here. Well, that's 2 planes intersecting. So even if I'm kind of confused, I can go back to my definitions. And it says if two distinct planes intersect, they intersect in exactly one line. And so they intersect at, let me erase some of this fine detail, line EB. But in this case, it's going to be a segment because it's a box, I guess. So segment EB is the intersection of those 2 planes. And so here's some of your practice. And the first thing that they give you is a plane. It says, what are 2 other ways to name line EF? Well, if I look at EF, I've got another point on that line is B. So I could call it BF, I could call it EB. So I'm going to go with EB. And then they also denote it. I've got a little lowercase letter, so I can call this line N. It says, what are 2 other ways to name plane C? Well, what are other ways to name a plane? Well, they have to be 3 non-collinear points. So let's do EBG. Plane EBG. So EBG, and then I could do FEG, FEG, or FBG. I mean, there's plenty of ways, there's more than 2 ways. Just name 3 non-collinear points. Okay, well, we just did a few. So EBG, BGF, and EFG, non-collinear. It says name 4 coplanar points. Well, E lies in the same plane as B, as F, and G. So E, B, F, and G. So this is kind of going to be your task here with your practice, is to label and kind of find things that are hidden within these images, kind of think about how things intersect. hopefully you'll have a great day with that. So, and then you've got some algebra review down here. So if you're iffy on these, all I can say is go and look at Unit 0 for algebra on my page or on their page, it doesn't matter. And then there's this nice little application one. So, and a nice little map here, so have fun. I'll see you later.